Good evening, and welcome to the All Portable Discussion Zone, a bi-weekly podcast focused on amateur radio, portable ops, QRP, homebrewing, and everything in between. My name is Charlie. FCC call sign is NJ7V, and I'm your host. And with me this evening are my Homebrew Workbench Roundtable co-hosts, Adam, K6ARK, and Tobias, KK7BCO. If you enjoy the show, you can find us on all the major platforms, podcast platforms, as well as on YouTube and Discord, and we'd love to hear from you there. You can find links to those platforms along with any resources and links that we have mentioned in today's episode in the show notes. And so, since Adam and Tobias are with me today, then we're going to be talking all about designing, building, modifying, and improving ham radio equipment. And it's going to be a fun show tonight. So let's dive right in. Tobias, he's been back from a very long and trudgery-driven hike to Soda Peak, but he'll update us on that maybe. But let's start by going around and seeing what's in everybody's workbench. Tobias, how you doing?
I'm really not too bad. Yeah, I guess since I last saw you, a couple of my main activities that I've done have been a couple of first activations for Summits on the Air that involved a fair amount of bushwhacking or off-trail hiking, which here in Arizona it generally involves not too much in terms of like low ground foliage, but quite a lot of spiky and snaggy things. So you end up kind of scratched and slide around on loose
Yeah.
rock and stuff. But yeah, one in the Superstition Mountains, one in the Goldfield Mountains, both of which had been on my sort of bucket list for over a year. So it was a pretty good couple of weeks, and getting a couple of new activations in there. And on my workbench, so where I left you off last week, I was talking about last episode.
Yeah.
I was talking about wanting to kind of expand on making one of these NVID half-wave micro tuners that also for soda that also has, so it's a NVID half-wave that you can adjust a little bit. The one that we were looking at before was this sort of Hendrix design that A5TB has drawings for, and there's a whole bunch of different versions of this where you have a very small polyvaricon and a little inductor, and there's usually an SWR bridge so that you can tune, and your QMX is perfectly happy with that. So after the last episode, I ended up going and sort of making loads of really crappy notes of
Oh,
schematics
look at
and
that.
drawing out all of these different variants and trying to trying to understand what I need to understand. And then I decided to go and try to throw one together. And this was where things got interesting because I kind of threw them on a board. I made decisions. I looked at the parts I had in my parts bins, and I went ahead and made a little Manhattan style test. And this is where I discovered that you need to go back and build one when you don't really know what you're doing. You need to go back and build one that you know is going to work first, and then start changing things rather than kind of deciding that you're going to take this little piece of this circuit and this little piece of another circuit and put them together, and this is going to work great.
Yeah.
Because it didn't work at all.
Oh, wow. Okay.
And so yeah, it's been interesting. It's kind of was like reminding me of what you really need to go back. I really need to go back to basics. And fortunately, when you're doing the Manhattan build, it's very easy to pull components off and sort of rearrange them and try things out. So my initial test did nothing, and then I rearranged it to look like the original circuit diagram that I was looking at, and then I was at least getting LEDs to light, but they're not turning off in the same way that I would expect them for this SWR bridge. So this is where things then get kind of interesting in the fact that what I really need is a better signal generator, because the one that I have only goes up to, I think, does it go up to like 1.5? What was it? 1.5 megahertz or something. So it's just kind of going in the bottom end of what I need. It's an old little HP one. So we might be building something that might help with this.
Yeah, we're going to talk about that for sure. Yeah.
And that's pretty much what's on my workbench right now.
Okay, good. That sounds exciting. That's good stuff.
Yeah.
So then you, yeah, you had that Manhattan build, and then you were able to kind of go back to the original construction and then try to start moving forward from there. That's genius. That's a good idea.
Yeah, and what I need to do now, because I was to test it, this is also part of it. So to test it, I was using the signal generator to inject RF into it, but it's putting out very low current. I don't know if it's enough to actually work the passive circuit, but it was lighting the LEDs. But I then also need some way of varying the dummy antenna at the other end. So what I did was I just put the antenna tuner that I had and sort of soldered it onto the end of it. But that's not working ideally. That was just a sort of thought, oh, maybe this will work. I think I need to work on that and just add the actual tuner to this board, which I had two polyvaricons. I've ordered some other ones. So I'll have some capacitors to hand.
That's really cool. I like how much of an experimental mind you have. You're like, well, let's see, let's just try this. Oh, let's just try that. That's great. You're
Well,
more
actually,
daring in that area than I am.
well, it was pretty low risk right here. I forgot that in that process, I have when you look at is it N6 ARA? Is that the one? Yeah. Is it
Yeah.
N6? Yeah, N6 ARA. When you look at ARA's micro SWR meters, they're a little inline thing that has two BNCs, one on either end. So you attach one end to the radio and the other end goes out to your antenna. And they just give you like a live SWR reading. And when you read his description of it, it says that it's based on the tiny SWR by what is it, DK3 IT. And you can buy the boards for that project, which are tiny. They're these tiny little things that are what, three-quarters of an inch long or something. And you can buy three of these from OSH Park for $2.30, including postage. So it's going to be quite a bit more just in the components to populate this because it needs a couple of surface mount components and a few LEDs. But I need to order those from. So I have three of these to play with, just to have something that's already half built or at least worked out.
Okay.
And then I also found another interesting one that is floating around on eBay and AliExpress and things. And I'm not entirely sure who makes this, and I haven't been able to track down because I briefly had a link to where the project I think this started from, but this is basically another one that if you go onto eBay or something and write in 10-watt QRP SWR meter, you'll end up with this little kit that's somewhere around $20, including shipping. And this has an Arduino chip on it. It has a microcontroller,
Oh.
and it's still passive, but it has six LEDs. I don't know, for those of you who are watching on YouTube, you can see that it has six LEDs at the top, and it will read your SWR on key down, and then when you let up the key for about 3 seconds, it'll show you that your power output, which is kind of interesting because it's still using the RF to power the chip. But again, I haven't soldered this together yet and put on its little BNC connectors because I'm not sure how I want to work with it yet.
Yeah.
I might want to incorporate it into a tuner rather than just using it inline. But we'll see.
That's cool.
Yeah.
Yeah, many years ago, I actually incorporated one of those DK3IT SWR meters into a mountain topper, an
Ah,
MTR3B.
nice.
And one little tip that you might consider as you choose components for it, if you haven't ordered them yet, it does have one LED, I think, to indicate forward power, and then three LEDs to indicate different levels of SWR.
Yep.
And on the standard design, they're all just the same color LED. And
Yep.
it's kind of fun to make them like yellow, orange, red if you want to make multicolor ones. So
Yeah,
that's what
that's
I
what I
did.
was planning to
Yeah.
do. The other thing that I found, the thing that's weird about that schematic is that there's another LED in it, which I'm guessing is just used as a diode. But I haven't understood that yet. There's one, two, three, four. Are there just four? Maybe they're just four.
Yeah, I think there are four on that one.
Yeah, it's an interesting design, and that goes back a few years. I think that was like about it was more than 10 years ago that they kind of worked that design out, and it's minuscule.
Yeah,
I don't know
it's
how you
cool.
managed to fit so much stuff inside the case of that little radio.
I know, right? I, I also put a capacitive touch pad
Yeah,
inside that one
exactly.
and a speaker and an amplifier.
What?
Yes.
Must be an empty case then.
There's a decent amount of space in there, surprisingly.
Cool.
All right, Tobias, is that what you got on your workbench? Anything else?
No, that's everything.
Okay, well, I think we'll go to me next then. I
Okay.
have kind of prepared a few things. I've got what, four different things on I wanted to talk about, and I'm actually prepared enough that I've got some web stuff up, like a browser. So let me make sure I get the right screen. And so hopefully I am sharing something. Is that
Yep.
it?
We've got it.
All right. All
Wacky
right.
key.
Yeah, wacky key. First thing on my bench is I wanted to enter a into the wacky key contest for the Ozarkon conference that's coming up in a few weeks, and I've made some progress. I will say at this point that what it is a Heathkit metronome that I found at the flea market out at Hemvention last year. Was walking through with Rex Harper, and he was like, "Let's do a challenge. You find something, and I'll find something, some sort of an enclosure, and the challenge is to figure out something to put in it." And so I bought this metronome, which actually works, Heathkit one, and I'm slowly trying to take care of the mechanical design of converting it without making too much outward appearance changes to it. And it's actually involved ordering some sort of a pendulum device and going to my friend's welding shop and having him do some TIG welding, and of course going to Ace Hardware and finding some. It's just been interesting, and I'm still kind of noodling what I'm going to do with some of the aspects of it. But it's been a fun project, and that's about all I'll reveal at this time because I don't want too many people knowing about it until it's done, because then I'm kind of skirting myself just in case I don't get it done by the contest. I'm sure there'll be other opportunities to enter it in elsewhere if I don't get it by then. But that's one thing. The other is I took this video here of our good friend NR7Y, who's on our Slack channel, Brian, and I think it's Brian, right? Yeah, I think so. And I followed his instructions to modify uh, this radio, this Quanching or whatever it is. And the interesting thing is I bought this radio probably 2 or 3 years ago and never adapted it. And then let me show you. When I opened up the box, let me not share my screen for just a minute so I can show you what strangeness there is. So it came with this cradle. Let's see, this plug on the charging cradle. Okay.
Yeah.
So I'm like, what the heck? How am I going to do that? That doesn't go in any outlets. So, and then also I was talking to Tobias and I'm like, oh yeah, well, he says, well, you can just use the USB port. And so I'm like, okay, I'll charge it that way. And this USB port is blank. There's nothing in there.
That's ridiculous. Yeah, just to show you that I'm not fibbing, that this is what's on my one.
Yeah, you can see it in there.
There's a USB-C port on there.
Yep. So I had to buy another one with the right plug on it. So that was an interesting thing. Because when I opened it to mod it, it was like it was like just one bar and it was about ready to die, and so I really couldn't play with it too much. But I did do the mod, and it was really quite easy and fun. And then I tested it in the CW, and it turned out great. So that was a fun little project. Didn't take too long at all. It's a pretty easy one. And so kudos to Brian and NR7Y for figuring that out. And I did have to put flash firmware on. I think that's part of the process with all the different variations. I didn't realize until after I'd done it that there's multiple variations of firmware and of different modifications you can do to these things. So that was pretty fun. Then the only other thing with that project was it was really hard to get the screw off of the antenna port right here for me. It was really tight, and so I had to really figure that out. It just took a lot of time, and I really almost stripped the thing getting it off. But I used the same tools that Brian did. Whatever.
Yeah,
Um,
So
Yeah.
on some of the, I don't know if you knew this, and yours may have needed to take it off, but on both of the Quanchings that I have, that nut was actually inside the plastic. It wasn't even holding the case on. So
Oh,
so you didn't have to take it off to get the
Oh my
case
gosh.
off.
Well, that
Yeah.
I I'll pretend like I needed to. How about
Yeah.
that? Thanks for telling me
and
that now.
while we're on that topic, I have mine set up with the IJV firmware, which I've been using to do single sideband or double sideband, um, and that's what I used yesterday. Um, I had some reports of me sounding not super clear, but I don't know whether that's the fact that this is a hacked radio, and I don't, or the fact that maybe the radio at the other end was had a filter set differently, so it was expecting something different. But um, people can still hear me and understand me, so that's fine.
Yeah, good
Yep.
enough.
My understanding on that from Brian and others that really understand, how it's modulating the different modes, is that while it's really emitting a true CW signal when you're operating in CW, the the dual sideband functionality on it is a very marginal representation of even true dual sideband.
Yeah.
So, so I would expect it to sound funky on a non-Quanching receiver. If it's going to another Quanching that's demodulating the same way it's modulating, then maybe it sounds a bit better. But it,
My
it certainly
understanding of
works.
yeah, my understanding in the manual is that it actually has like it's a true single sideband demodulation, but
Mm,
it's the way that it's modulating that is the funky.
okay,
Um,
interesting.
but I've made a few contacts with it and it's fine. It's just um, I wanted to save a little bit of weight over taking the 817 and taking a QMX, and that was I think 600 grams lighter than the 817, which I then stuffed 800 grams of pretty rocks in my pocket on the way up the hill instead.
Okay, well, okay, so that's a fun project. A lot of different resources out there. The other thing I wanted to show you was I got a care package, so to speak, from Mike N4FFF and Becky N4BKY for it's Ham Radio Duo. They sent me a key and a paddle. Let me grab them here real quick. So, all right, so they sent this kit here of a key. You can see there's these parts here, and then the case, and they sent me the cable, and then also they sent this straight key, which is really nice. And so I'm planning on taking these out in the field and using these and reviewing these. But it was fun to get that from them, and they have this website. Let me share my screen again and show you their website. They have this website where they it basically says on their website that our mission is to get as many people into the hobby and enjoying CW as much as they can, and they hope that they can make it the CW accessible by providing these tools. And so they have some great tools other than just providing the paddles. They've got this software. I guess I'm assuming that Mike is some sort of a software engineer because he's got all these ham radio tools available. And here's his YouTube channel. So they have some cool stuff. So I really appreciate you guys, Mike and Brian, Mike and Becky, sending me these to review, plus all this other good information about what you guys offer. So that's really cool. So the last thing I wanted to mention, the last two things really aren't Workbench related, but they're things I wanted to mention is this YouTube QSO search to allow you to see yourself in YouTube videos if you've made a contact. And I got an email that said, "Hey, check this out. You're in a video," and then I clicked on the link and it brought me here. And I'm not sure if I'm going to be able to. Let's see if the sound is on. Advanced options. I don't know if you're going to be able to hear the sound or not. But when I click on this, you can see all the timestamps, and it takes my call. It takes me right to my call sign. Can you hear the sound? That's all right.
No.
But what I'm hearing right here is the QSO between me and this guy,
Hmm.
and so it's pretty cool. The email I got, I asked, hey, this is the email, what it looks like. Watch the video. And it's VE to ZDX tools. And I said, that's pretty cool. I emailed him and said, that's cool. How does it all work? And he says, the video needs to have YouTube chapters. And then you have to basically send it make it indexed. And so, but he says it's all on the website to understand how to use it more. I haven't dove into that yet. It seems like it's pretty easy to use, but the cool thing about this is if you're recording yourself and you're putting it up on YouTube, if you interact with this tool, it'll make it so all the other people can see you, hear you, and see you and their Q cells. It's kind of fun.
Hmm.
That's neat. I maybe this already exists and I'm just not aware of it, but I'm sure it's only a matter of time and probably not a whole lot of time before someone designs an AI tool to translate Morse code into a transcription and then even perhaps identify call signs and build chapters like that for your video. That would be pretty sweet.
It would be, yeah. I think you're right. We're on the verge. If it hasn't even already been created, then it will be shortly for sure.
Yeah.
Yeah. All right, Adam, I think you're up. What's on your workbench?
All right. Well, last time I mentioned, a couple of things. I mentioned that 40-meter Moxon, and I still haven't cut the wire for that. I've been pretty busy over the last month with search and rescue training and things like that, and just haven't gotten around to it yet. But I do need to finish that 40-meter Moxon up. The other project that I mentioned was an amplifier for 4 days in May. The contest this year is to try to build a crystal oscillator driven amplifier that transmits between 4 and 6 watts of CW on 40 meters, on 7 megahertz. And what they're going to measure as the contest is the input power and the output power and the ratio. So the efficiency of the transmitter on its consumed power. And the closer you get to 100%, the more likely you are to win. So,
Nice.
so I took that as a challenge. I've never even designed my own oscillator before. I've assembled kits and pixies and things like that have a Colpitts oscillator, and I have learned a little bit about oscillator designs and amplifier designs that way, but I am very much a novice at this. So I started doing some research. I decided I want to pursue a Class E amplifier, which from what I understand is a solid challenge because they have their quirks and difficulties. You have to drive them with a square wave, so I have to figure out how to make a crystal oscillator provide a square wave as an input to an amplifier, which will be a fun challenge to learn how to make that transition and have the right type of device to provide that. I've purchased a couple bags of parts from digikey to start tinkering with, and I've got some prototype boards to experiment with. I've successfully built an oscillator using the parts that I bought, just a basic crystal Colpitts oscillator. And I started doing a little bit of modeling in LT Spice because just like designing antennas, having a computerized tool like that to simulate your circuit and then compare that to your results can really tell you a lot about what you can expect, and then when you get your results, you can compare the two and try to figure out why you're getting different results than you expect from the model, and that's where a lot of the learning happens. So I started doing some modeling in LT Spice, and I ran into a problem designing my crystal oscillator. I found that to enter a crystal, I couldn't just put a 7 megahertz crystal in there. I had to put a number of values: series inductance, series capacitance, series equivalent series resistance, and then parallel capacitance, or the case capacitance essentially. And I didn't know what those values were, and I didn't know how to measure them. So that sent me down another rabbit hole that I'll talk a little bit about later in the show here when we go down the road of tools that we have on our workbench to figure these things out. So I'll I'll tease you guys there and save that for a little bit down the road. The other thing I did on this project to set me up for the next couple weeks of experimenting is I designed a PCB that will relatively easily allow me to build and tinker with various Class E amplifier circuits using different transistors and things like that. So it's just a tool that will, because I've set it up, you know, with more proper short traces and things like that between my capacitors and my inductors, I'll get a lot less of that sort of parasitic capacitance and inductance from leads between different components on a
Yeah.
you know, on a prototyping board. So I think we'll see. I think this is going to help me a little bit in
That's cool.
achieving a result that's closer, an actual result that's closer to my model than I might achieve otherwise. So
That's a really neat project.
yeah. So the other thing on my workbench right now is one of the things that I like to do a lot is take an existing design and modify it, usually make it smaller, um, among other things,
Of
and or
course.
add features to it. And in this case, I came across, thanks to Doug Hendricks, I came across the WB2CBA, Whiskey Bravo 2 Charlie Bravo Alpha pocket tuner designed by a guy named Barb, who is usually at 4 Days in May. Really cool guy, and inventor of many a neat project and kit. Um, so he came up with this thing. It's on GitHub. It's very easy to find if you search his call sign, WB2CBA pocket tuner. Um, it's about the size of a credit card, and it's a pi match tuner for roughly 7 megahertz through 28 megahertz. And it's a cool design. Instead of variable capacitors, it uses a 16 position switch to switch between values of fixed capacitors that it applies in various, you know, almost like binary code of you know, putting those capacitors in parallel, so you get higher values of
Right.
capacitance across a broad range. So I took that, and if you're on the video, you'll be able to see it. I took that and miniaturized it. So this is a tiny tuner that's maybe 2¼ inches long and about 3/4 of an inch wide. With this one has SMA connectors on each end, and it is that essentially that same tuner, but in an even more miniaturized size, perhaps to stick in the key pocket of your pants rather than your standard pocket.
That's really
Um,
cool.
yeah, so it's been fun. This prototype does generally work. The SWR meter portion of it, I need to tweak a little bit, and then I have some design modifications I want to incorporate, which include. Um, so as I noted, it's a pi match, which means it's got a series inductor, multi-position switch for a series inductor, and then shunt capacitors on either side of that. Um, and what I'd like to do is, rather than just these fixed switches at the top here under my index and middle finger, to add a large value of fixed capacitance. They're 2 position switches. I'm going to make them 3 position switches and then have a bypass mode, so you can essentially turn it into a high impedance L match network or a low impedance L match network, for, you know, for when you might want to go with one of those options and really optimize the efficiency of your tiny pocket tuner.
That's
So
a brilliant mod. That's
yeah.
neat.
So I'm going to share that with Barb at 4 Days in May. I don't really want to add another product to my page, but I'm already getting people requesting these, so I'm sure I'll make at least a small batch. Please don't
Yeah.
don't reach out to me at this point. Give me a little time. But who knows? Maybe I'll have some of these at Dayton Hamvention. So that's probably a good place to flag me down if you're interested in this. And then in true Barb fashion, I will, with his approval, share this design for others to have built as well.
That's awesome. That's perfect. I'm totally impressed with that.
But
Hopefully hopefully you have it done by 4 days in May so that well, I'm not going to be there, so I'll have to have somebody grab one for me.
Oh yeah, we can make that
Yeah.
happen.
just out of curiosity, if would dip switches work for making it even smaller?
They would, but I think the convenience factor is worth the slightly larger size
Okay.
of these,
Yeah.
maybe down the road I go the what if we even make it more smaller
The sub miniature
road
version.
That's
and
funny.
have some more fun with it. But I think for now, this is kind of a nice balance of this is already really small and
Yeah.
but also usable.
Yeah.
All right. What else is on your bench? Is that it?
Yeah, those are the main things right now. I think
Okay.
that's the kind of key stuff worth mentioning.
Perfect. Okay, good. All right. Well, let's move on to the next section of our podcast then, which is our talking about our group build. So, last episode, we talked about the idea of possibly doing a group build. And since then, I've kind of taken on that challenge and did a lot of work in figuring that out. You guys may have some good input and may have some things to add, but let me just run down what I have done and what we're going to do as far as the first project, and we can do more if need be. But in Discord, on the Solder Smoke Discord server, I posted this in the general chat on February 4th. It basically said that I am planning on doing a small build projects, a series of those through this podcast for beginners. And what I did was I dug through a bunch of great resources, Hans Summers' 4 Days in May QRP article from 2024, some book by Drew Diamond called Radio Projects for the Amateur Radio, or for the Amateur, and then Doug DeMoss W1FB QRP notebook, and then some experimental methods in RF design. So those books, I scoured through those and looking for the top beginners projects that people could build. And so I came across a list of an SWR meter, an antenna tuner, a signal generator, a frequency counter, simple transmitter, and a simple receiver. And then I posted this and said, hey, people in Solder Smoke podcast, what do you think? These, others, add to, subtract from? And I'm not going to bore you right now with the details. You can go ahead and go to this server, the Solder Smoke server, and go under general, and you can see all the comments. But generally speaking, it was kind of an agreement that the list I had was pretty good, plus some additions that we'll look at. But basically, I think that we would like to just start a series, and we'd like to start building some of these little projects together, the three of us, and then whoever else would like to do that. And I talked to Dean from the Solder Smoke podcast, KK4DAS, and asked him if we could use the Solder Smoke podcast Discord server to kind of be a landing spot where we could communicate and collaborate. And he said yes. And so those of you who are watching on YouTube, you can see at the very bottom of the channels on the server, there's a beginner project series, and there's a test oscillator chat in there. And so that is where we'll go for this first project, which is going to be a test oscillator or a signal generator. And I reached out to Steve Hartley, G0FUW from the GQRP Club. He's the chairman of that, and I've had some good correspondence with him in the past, and asked him what he thought would be a good project. He actually sent me Reverend George Dobbs' test oscillator article, and this is what we're going to, and this is what we'll be building. And so I'll post this there in the Discord channel, and it'll be available. The challenge is for all of us to read the article and then to find all the parts in the schematic and to build it. And there's enough information in the article, I think, for everybody to do it. And if you get stuck or have questions, then go to the Discord channel, and us or other people who are a lot smarter than me anyway will be able to help you out. A few things to note. When I was reading the article, I was like, I learned something new. I'm so new at Homebrew that this is going to, a lot of people will be like, oh, that's, everybody knows that, but I didn't. I read that it needed that a basic oscillator, which is part of what we're going to be building, needed a buffer amplifier. And I'm like, oh, buffer amplifier. Okay, so make it louder. And then I'm like, wait a minute, is that really what a buffer amplifier is? And no, it is not what a buffer amplifier is. A buffer amplifier, unbeknownst to me, is basically a device that sits between the oscillator and your whatever you're putting the load on to make sure that it doesn't draw too much current, or just so that it keeps it stable. And really has nothing in my mind to do with actually audio amplifying. It's just a kind of a buffer to stabilize things. So learn something new there. And that, I think, is the idea for all of us beginners. Is as we go along, we're hopefully learning new things. So the one catch with this is it has 3 inductors that cover all the ham bands, and actually it covers most of the ham bands for the United States. And those inductors, 45 microhenry and a 5.3 and a 1.2 microhenry inductors. The original schematic calls for them to be like these tunable ones, and I'm going to go to YouTube or to eBay real quick and show you. They're like this spectrum type transformers, Toco type things, and if you look right here, they're available to buy, but $18.77 shipping for each of the components. You get 5, and then the $8.04. If you wanted to get all 3 of them, you'd have to buy 5 of each, and you would end up spending $80. So that is kind of like, for most home brewers, that's kind of outrageous and something that maybe you wouldn't want to do. Maybe if you get together with 5 of your friends, it would make it more like, I don't know, $15 for one of each or something like that. But I don't think we're going to do that. You're more than welcome to source parts that way. You could also kind of look for, like here's on one of the distributors, the Newark distributor. There's a toroid for the 45 microhenry already wound for you there. Reasonable price, but I haven't tested it. I don't know if it works. But Steve Hartley, who was helping me out on this, he sent the turns for turning your own inductors. The one that's going to be the most difficult is the 45 microhenry. It's 88 turns over a T68-2. And I have already tested that. Let me stop sharing my screen for a minute and show you. I have right here an 88 turned inductor, if I can get it on the camera properly. And I've tested it on my inductor tester or whatever it's called, and it works. In fact, I have a picture of that. It was 44.8 and we wanted 45 microhenries, so I think that one will work. So we're in good shape. I know for sure this one, the 45 microhenry, will work. Some of these others are less turns, and the thing too to remember is this is a all band signal generator. So if you feel like you're not going to do 80 meters or 160, then the 45 microhenry, you can just eliminate it from the circuit. Or if you think you're only going to do like 7 megahertz, then all you need is the 5.3, and it'll cover those frequencies. So there's a lot of play and experiment and kind of build it the way you want it opportunities here. So I think that's going to be a fun project. Wanted to shout out to Rex Harper, who's helped me a lot on figuring out the inductance values as well. And so, I mean, we've got the Solder Smoke podcast helping us. We've got the GQRP Club helping us. We've got Rex Harper helping us. And it's going to be a fun, I think everybody's willing to just, contribute and help us get along on these projects. So the first one, again, is this one. We'll put it in the Discord channel, and I will pin it. And so you'll have to go up here to this pin to see it. I'll pin it up here and all the information when you go to the channel, and it'll be available. So I think that's about it. Any questions?
So it took me a minute to find it. Are you going to link the Discord channel in the show notes for everyone?
Oh yes, for sure. Yeah, awesome. I'll link the invite so that people can get there for sure. Yes, absolutely.
Yeah, unfortunately, it's not searchable, so you do need the link. I was able to find it by going to the Solder Smoke the Blogspot website, and then do a search for the word Discord on their page, and found it that way. But yeah, and then it's let's see, the channel or whatever it's called that it's in
Server.
is no,
Oh, yeah.
the
Yeah,
the
yeah, channel, I think.
channel test oscillator, I think is the
Yeah,
title, right?
so
Yeah.
Yeah,
so it's the
cool.
Discord, the Solder Smoke Discord server. It's the beginner series folder, and then yeah, the channel is the test oscillator. Cool.
Very
Yep,
cool.
yep. And I've already got requests for other stuff, and the list is it's gonna. I have a list of beginner projects that's gonna last. I mean, if we want to do this, it's gonna last us a long time. So
Perfect.
just
Yeah.
imagine, it's just a matter of choosing them.
Yeah. One thing I wanted to add for some other listeners is the fact that I've always found the existence of show notes a little bit hard to find. And our show notes are going to be on YouTube. So even if you're listening as a podcast and you need that list of parts, some podcast platforms will list the show notes, but most of the ones I've tried don't. So just go to the YouTube and you'd be able to find those.
Cool. Yeah, I'm excited about this. I'm really gonna have fun with this, I think. So, all right. Anything else on that? Any other thoughts on projects coming up that you'd like to do after we do this one? What do you think?
You're the one with the master list.
Okay. All right. All right. Well, if
the
you,
the one thing that I'm going to try that I have no idea if it's going to work. I was looking at the number of windings and decided that going for the 88 windings or something was going to be a little bit tedious putting it through a round through a donut. So I happen to be dismantling an old AM/FM radio in the shed. So I'm going to take the ferrite core that's a cylinder out of that, which I think is probably about 10 by 120 millimeters or something. I haven't taken it out yet. And I'm going to try winding on a straight core because if I can get 3 windings on a single core, that should be okay in terms of the stray capacitance. And it should, in my mind, make it easier to wrap 80 something windings in a line. So I'll let you guys know. I mean, the whole point of this is that we'll hopefully sort of let people know as we go along how we
experiment and
progress. Yeah.
try different things. Yeah.
Yeah, and I'll caveat this by saying I have not yet read the 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 instructions or the article on that build. Do you know how precise the inductance needs to be, or how accurate
Yeah.
that measurement needs, the
Not
value needs
extremely,
to be?
not
Okay.
extremely, and you've got that variable polyvaricon capacitor, so that with that you can be off by a little bit. I
Yeah.
don't think that the reason he had that the design called for the tunable inductors is just because that's what they had on hand. So it
Okay.
didn't it wasn't like anything special. Yeah.
Okay. Yeah, part of my thought was just I noticed they had a dial on there with numbers or gradients on the knob, and I thought perhaps they were using the tunable inductor to try to make those values on that knob usable or
I
something.
think that's I think that's true though. I think that I mean while it isn't really necessary, I think that that's the way Doug DeMaw built it. He actually tuned it to fit those dials. I don't think I'm going to do that, but
But that definitely is the polyvaricon with a vernier dial on the front. So I think yeah, he
yeah,
would have
yeah.
tuned it so that the actual numbers match up. That's clever. So maybe we need to build a signal counter afterwards to put that on
There you
so
go.
that we can actually check what frequency we're oscillating at.
Yeah, cool. All right, well, let's circle back around to Tobias and let's take it one at a time. How about we just do one and then go to the next person and just kind of do a round robin of Tobias, myself, then Adam on the workbench tools we think are important or that we like or that we want to talk about today. So why don't you take it away, Tobias? Tell us your first one.
Well, I have some pretty basic things here. I for years used see if I can get this out without knocking. For years, I used a very sort of normal side cutter that has sort of, you can see that it has normal blades in it. And then for a short number of years, I've been using flush cuts. And these are just very generic flush cuts, maybe even from Harbor Freight. I don't remember where they're from. It's amazing how much easier these are to work with in terms of when you're trimming off your legs. makes a much cleaner cut. When you're trimming a zip tie, it makes a beautiful clean cut without leaving a razor blade to hurt your finger later. Fantastic tool. Highly
Cool.
recommend it.
Yeah.
And then another tool that I've discovered by accident is this Knipex enameled wire stripper, which is well, we'll put the tool note in the notes, but it's the Knipex 1511-120, and basically it's like a pair of weird tweezers that have little teeth on its blades, and they make these in like 3 or 4 sizes, and you just kind of clamp onto. Well, I have a resistor here to demonstrate, but you kind of clamp on, and then you kind of strip away, and it's quite a bit easier than using a razor blade and some sandpaper or something, the way that I've been doing it for ages, which often ends up with having quite an inconsistent solder joint. And especially when you're like me and you're using a variety of enamel wires that come from different sources and you can't remember which one actually burns off with the soldering iron, which one does, you end up, I mean, it's a lot easier, a lot better to actually strip it off before trying to do that.
I love that. I
Yeah.
need a pair.
Yeah. I'm getting a second set of the tips from digikey. So you can get this from digikey as well. This one actually came from Amazon, but they only sell it with one set of teeth on them. And I think the tool with its initial tool is around $20 or $25. Then one other thing, which I think will be useful on this project for sure, is an LC meter. And this is the cheapest version that I'm aware of. An LC meter reads capacitance and inductance. And this little guy costs, I think I found with postage, it's around $20 on Amazon or eBay. But it's a bare PCB. There are 3D printable cases. It's crude, but it seems to work. So my multimeter will do some capacitance, but it has a fairly limited range and it does not do inductance. So I needed to have this to be able to try to measure the inductance of windings. And it has little leads here, and this one is powered with a mini USB or a barrel connector. And I think they might now make them with USB-C on them instead of the mini. But mini's a pretty decent interface. And it's small enough that it fits in a bar of soap box. So that's where that lives.
Nice. All right, good
Yeah.
recommendations. That's I am obviously all those I have on my bench, so that's great.
Mhm.
Except for the wire strippers, I have a X-Acto knife is how I do it. Everybody does
Yeah.
it differently, right?
Well, that's how I have been doing it for ages. It's just that I always end up with the solder sticking on one side and not on the other because I've missed a little bit, and sandpaper that I have to find on the workbench is too coarse or whatever.
Yeah.
Yeah.
Yeah, a couple of comments on those. I've got those same wire strippers and they are fantastic. Flush cutters are awesome as well, and I will say that it's tempting to spend $6 or $8 or whatever it is and get the really cheap ones, but it is worth it to buy like Knipex brand flush cutters. They're just much higher quality. The blades come together at the right spot and marry up well. And Knipex has for, yeah, I don't know, maybe $5 more or maybe a little bit more than that. They have a special model of those with a little wire that runs out to the tip of the blades, and it actually catches the lead that you're clipping off. If it's a piece of wire lead, it catches it so it doesn't fly across the room and end up in your carpet or perhaps in your foot later.
That's slick.
I
Yeah,
need, I mean, on that topic, I need to find it again. There's a Japanese tool brand that makes a flush cut specifically for cutting zip ties. So from my memory, it's been a while since I've used one. Basically, at the base of the jaw, it has a little tiny pair of pliers that are designed specifically to
right.
grab it and tighten it. and then you
Nice.
make the flush cut.
Oh, that's cool.
Yeah,
But yeah, I highly recommend the Knipex brand flush cutters, particularly the ones with that little
nice.
lead catcher wire. And a word of warning on those. Um, don't try to cut larger wire or steel wire. Stick with, your copper wires and your component leads. Otherwise, you will dent or damage them. You use your heavier duty side cutters for the heavier stuff.
Yeah, definitely. That's why I have the cheap ones.
Yeah, even like 26 gauge poly stealth, it's copper clad steel, and that can damage your flush cutters.
Okay, cool. All right. Well, okay. So my tools, I guess we'll do it this way. Yeah, we'll do three at a time or just the three that we have or whatever. First one, I'm talking about on my Workbench tools. I'm going to focus on the tools that I travel with or that I plan on traveling with and haven't yet. Either way, I've kind of learned after being at 3, 4 days in Maze and other conferences that I need to come up with some portable Workbench items. And so the first one I'll mention is the Pine Sol, which I know many people have. It's a really, really effective tool. I actually have the adapt. You can't really see them well. There's the extra tips that you can get on Amazon to add to them. But this little device, it works just as well, in my opinion, as my soldering iron that I have on my Workbench. I've used this for several projects recently, and it works just fine. A cool note to add to that is that there's some firmware that makes haven't done it yet, but you can flash firmware on here, and it gives you some other extra really cool things about this. Maybe Adam knows more about it than I do, but I just read that it's highly recommended to get the firmware, and so I have that, and I have not used it with a battery, but what I do have is this power block, and I just plug right into the electrical outlet. So if I guess I'll be at Ozarkon this year, and so I'll just find an outlet, plug it in, and plug the pencil in, and I'll be good to go. And it'll be very low profile. I don't have to carry a big old honking piece of equipment with me in my suitcase. It's very packable. So that's the first item. Let me pull this out and show you. It's just a cable and basically a wall wart dish thing. So that is my soldering iron that I'll be traveling with. And so I'll just go ahead and mention item number 2, which is an RF probe. And I'm going to share my screen in a minute, but what I have here is this Homebrew RF probe, and it's just made with a few little components, and it is extremely effective in just if you're probing a Homebrew project, you don't need to know the exact RMS voltage. Oftentimes, you're just trying to figure out, is there 5 watts or not? Is there, or volts, 5 volts or not? And so this RMS probe made with just, I think, 3 or 4 components, you can make easily, and I'll throw up the schematic in a minute, but it'll get you close unless you're below half a watt, and then the diode in there it doesn't work properly because it's not getting enough drive, but otherwise it's surprisingly accurate. And that was one version. I have another version built using the QRP Me pads.
So
Yeah.
so given that it has a diode on it, I'm assuming you're just connecting this to a digital multimeter and
Yes.
measuring DC voltage then.
Is exactly, yes. That's exactly
Cool.
what yeah, exactly. So on the end of here, we've got 2 plugs that go into the digital multimeter, and then on the other end, we've got the probe end, and then a little clip for the ground. And so yeah, you clip the ground, and then you just start probing and look at your digital multimeter, and it will tell you pretty closely how much RMS voltage you have in your circuit.
Nice. I
So
like that.
yeah, it's easy to build. Let me just bring up my screen here real quick and show you the schematic so that we have that as well. Let's see.
So this is a side quest. This is
Yeah,
not one of our build
it's
projects, but
not
it
because
is it's so simple, and I haven't done it yet, but I'm totally amazed at how simple it is. I just need to get myself a 5711 since I have a bunch of other diodes, but not that
yeah.
5711.
So this is a look at it. It's basically a 1 in 5711, a 4.3 mega ohm resistor, and a zero 0.01 microfarad capacitor. And you are good to go, and you can see where this plugs into the digital multimeter. So good piece of equipment. I travel with because I don't want to take my oscilloscope and other big gear, but with this little probe and my digital multimeter, I'm good to go with testing a few things out. So, and just real quick, here's ChatGPT says at levels of 1 to 2 volts, we're good, but if you go lower than a half a volt, then the output collapses and whatnot. So um, basically, it's pretty accurate. So then I'll just mention the last thing, and we'll turn the time over to Adam. And the last thing that I learned this one from Rex Harper. I saw him use it, and I'm like, oh, I got to get one of those. This is my another travel item. So all three of these are items that I'll be taking with me to HozarCon. And it is, if I can get it out, a
Whoa.
magnifying glass. And it has a light that you just push the button here on the side, and the light comes on so that you can look at what you're soldering and look through the glass there. So I find it very useful because the magnifying glass I have over here is connected to the desk and not portable, but this one is, and it's just on Amazon. I just found this on Amazon. I'll put the link. It's really cool. So those are my 3 tools for travel. All right, Adam.
Very cool. Well, I think I'm going to limit mine to one, but this thing is truly a multi-tool of a workbench. And just recently, I've started learning a lot more about it and all the cool things you can do with it. It could even be used as a signal generator if you need a signal generator for a project. It's something that you can use to measure the equivalent series resistance, the series capacitance, the series inductance, and the shunt capacitance of a crystal. It's something you can use. What it probably gets used for the most to determine the SWR of an antenna and tune an antenna. It's your nano VNA, and you can use it to measure an inductor or a capacitor as well. So it's an incredible multi-tool. And just recently, as I've started to go down the road of trying to use LT Spice and understand those different parameters of a crystal, I started researching, well, how can I figure that out? What tools do I have to figure that out? Yeah, I could build an oscillator with a known inductor, a known capacitor, and figure out what those parameters are of my crystal. But I can also just hook it straight up to my nano VNA and measure it directly. Um, I do also have that LC meter that Tobias showed, and I found it does pretty well for, mid to larger values of capacitance and inductance, but it really struggles with the smaller values. And the nano VNA seems to be a bit more capable of accurately measuring those smaller values of inductors and capacitors. So that's my hot tip for the tool, and you can see my fancy adapters there. Just a couple of alligator clips hooked to the center pins of some BNC connectors, and then an alligator clip on a ground lead there. And yeah, there's some compromises being made from a test device standpoint with having that much metal out there on the outside of the unit. But if you calibrate with those things in place, you can mostly cancel the impact of that out. And so that's my hot tip for a tool that most of you probably already have and are probably only using one of those devices, the main blade and that Swiss Army knife, and there's a whole bunch of other sub tools in there that you can probably get a lot of value out of. So do a little
Yeah,
research and see what you can come up with to use your nano VNA a little more.
I love that. I totally agree with that. In fact, for me, I'm the guy that just uses the main blade. Really,
Yeah, same.
I've kind of ventured out and used one of the other blades, but but the problem I have is where do you find out how to use everything? And
Mm.
without I'm always, I know it just seems so delicate. Like if I do something and it's going to blow it up or something, but maybe it's not as delicate, and you just need to kind of experiment, or maybe you need to go out there and ask other people. I don't know.
So it's a It's a good question, and I have three answers to that. A couple that I've done so far, and one that I should do that would probably help me a lot more. Um, the third one that I haven't done that I should do more is read the manual because I'm sure there is very good, probably Wikipedia style manuals for nano VNAs that explain all these things and all these different features. Um, the first thing that I did was do what a lot of us do and just go search YouTube. And I searched nano VNA measure inductance and found, a dozen videos of people demonstrating how to do this in multiple different ways with the same device. And in some cases talking about, the pros and cons of that. So just some web searching, AI searching, or YouTube searching will guide you to a lot of good answers there. And then the the second thing that I did, did three in one. The second thing that I did, I just started poking around in the menus in the Nano VNA and looked at the different settings and options and functions in there, and I was like, oh, there's a setting in here to measure crystal parameters. So I tapped on that, I hooked the crystal up, and it gave me some weird numbers, and then I did a YouTube search for it, and I figured out that I had the crystal hooked up incorrectly. You need to do an S21 measurement rather than an S11 measurement, which in hindsight makes sense. And lo and behold, it spit out all my crystal parameters right there. So yeah, YouTube search, poke around in the menus, and just start asking questions about what you see there. Maybe try some things, and you probably aren't going to break it. And then read the manual because I'm sure the manual has a lot of this good stuff too.
RTDM, right? Read the damn
Yeah.
manual.
Yep.
Or RTFM, I think.
Well,
Adam, would these work? The oscilloscope probes?
They probably would, and
Because
I'm sure you could do the same type of just calibration with the probes in
I
place.
thought so, because everything should be coaxial and fairly well shielded on these,
Yeah.
and they also generally can take off the pinchy bit and just have a pokey bit,
Yeah.
which is kind of useful probably.
I suspect they would.
yeah. Okay, on to the next topic, if there is one. This is kind of open forum. If I don't have anything else myself, but is there anything else that either of you would like to talk about before we wrap things up?
I don't know that I have anything to add. I would just comment that if I think the build project's going to be a lot of fun. I'm looking forward to that. And looking at that right away, I had kind of the same question. I think Tobias mentioned. It sounds like we're going to need to build a frequency counter too.
Yes,
So
maybe that's
perhaps
another
that's the next project.
project, second one. Yeah, for sure.
And that's where I was going with the fact that I kind of need a signal generator to work on my SWR meter and tuner that has a better range than the one that I have up on a shelf. So this should be useful directly on the workbench. So yeah, looking forward to that for sure.
Okay, well then, in that case, thank you both so much for joining us today and being part of this group. It's a lot of fun. I enjoy this group a lot. I look forward to coming on and talking about all these things. If you're watching, we'll look for you in Discord in that channel, and we'll chat with you there as we move along on the project. And we'll see you again, I guess, in roughly a month. We're just kind of being casual with when we release these segments of or these episodes, roughly maybe once every month or two. But we'll when we have more material, we'll come out and release another video. So. Thanks everybody for being here. Thank you guys. We'll catch you next time, Tobias and Adam, and we'll see everybody later on down the road. 73.
73.
73. Thanks for hosting, Charlie.